Okay, this is part 2 of our introduction to special relativity. Last time we looked at how a particular problem with measuring the speed of light from different reference frames was leading to a lot of confusion because scientists expected that if a car, say, were moving at 30 meters per second and it turned on its headlights and the light came out of the headlights at 300 million meters per second, it should follow a very basic rule that you add the two velocity vectors and get 300 million 30 meters per second for the velocity of light as it moved across the road. And that's not what the experiments were saying. So Einstein saw this as a problem like others, but he saw a bigger context to it. He recognized there was a problem with this rule that you could just add velocities together. So again, if we take as our basic rule that V1, or V rather, equals V1 plus V2, this was assumed to be true that you could add the two velocity vectors, and Einstein seen that's not compatible with the experiment that the speed of light should be the same even when the car is coming towards you. But he saw more deeply than this. This wasn't the only problem with changing reference frames, when how you transform the view of things from one reference frame to another. So it's said that from very early on, Einstein was thinking about what it would be like to move along with a light wave if you could actually go that fast. So we'll take a look at what a light wave would look like in an electromagnetic wave here. And I've got a little simulation which shows, again, what happens if that light is moving. So we click on this and we kind of see these light waves move along. Well, as you visualize that, Einstein said, what would happen if you could move at the speed of light? If you could move at the speed of light, then you'd be riding right along with one of these waves as it traveled. So you'd be right on this point moving along. And that's a problem because according to Maxwell's idea of an electromagnetic wave, it's the changing electric field. So that's here in yellow. As you change the electric field, that's what causes the changing magnetic field in blue. And likewise, as the magnetic field changes, that's what causes the changing electric field. If you stand at one point, for example, if you stand right here, you have a changing electric field as it goes by, and then a changing magnetic field, and that all works. But if you ride along with the wave, so if you follow along here, always staying at the same point, then the electric field is always equally strong. And that means it's not changing, which means it wouldn't cause a magnetic field. And likewise, the magnetic field there would always be the same strength, and it wouldn't cause an electric field. So light couldn't propagate. Light wouldn't be light if you were going along with it. And that's a real problem. In one reference frame, the light's moving past you, it's there, it carries energy. In another reference frame, if you're moving with the light, suddenly it wouldn't be there. The electric fields and magnetic fields couldn't induce one another, there would be no energy. And so that represents a real problem as well. So those are two problems that Einstein had with this idea that of how you transform reference frames, how things look in one compared to another. The idea that the speed of light from experiments was coming out as constant, and yet according to this simple rule of V equals V1 plus V2, you should be able to add on and get 300 million 30 meters per second. Another, that it didn't seem like you could go the speed of light. But there was a third problem too, and that was related to magnetism. In the laws of magnetism, we know our right-hand rules. We know, for example, that a moving charge will create a magnetic field. And we know that if a charge is moving through a magnetic field, if a charge moves through a magnetic field, it's going to feel a force. Those are given by a couple of our right-hand rules. Well, this is a problem too when you think about changing reference frames, because who's to say whether the charge is moving or not? If in one reference frame a charge might be moving past you and creating a magnetic field, but if you move along with that charge, then suddenly no magnetic field would be created. So you'd have a field in one reference frame and not in another. Or if you had a charge moving through a magnetic field, a field that already existed, in one reference frame that charge is moving through the field, it feels a force. But if you're moving along with that charge, suddenly it wouldn't feel a force. So the same charge in one reference frame feels a force, in another reference frame it doesn't. So these are kind of three different examples of where Einstein was seeing trouble with what happens when you change from one reference frame to another. So he suspected there was something bigger going on, There wasn't just a problem involving measuring the speed of light from different reference frames, but there was something much more fundamental about how you change from one reference frame to another, that maybe our simple equations to go from one to another weren't correct. And he was bold enough to then say, let's go back to the beginning, and from the very beginning, rethink about how physics should look if we take into account a couple of basic assumptions. And that's what we'll talk about in the next part.